My name is Flashlearners and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. This is episode number 31 of the 120 Days to Jamb Chemistry with Flashlearners. In this episode, we shall be looking at Redox reaction. Redox reaction is simply referred to as oxidation, reduction, reaction. It is a reaction where oxidation is taking place and reduction is taking place as well. Then we begin to wonder, how do we know that oxidation is taking place in the chemical reaction? How do we know that reduction is taking place in the chemical reaction? In fact, what is oxidation? And in fact, what is reduction? Oxidation and reduction can be defined under 6 headings. These are the 6 headings which we can define oxidation and which we can define reduction. Oxidation and reduction are opposite, which means if oxidation is addition of one thing, reduction will be removal of that thing. If oxidation is the removal of something, reduction will be addition of that thing. For example, in terms of oxygen, oxidation is the addition of oxygen and reduction is the removal of oxygen. You see all these signs here. These signs are for oxidation. Plus, minus, plus, minus, plus, minus. Which means reduction will be opposite of these signs. Once again, I said that in terms of oxygen, oxidation is addition of oxygen and reduction is the removal of oxygen. Look at this equation. We can call this iron 3. Iron oxide plus carbon monoxide reacts. What happened? In the product side, you see that this iron oxide is now iron. What is happening? Oxygen has been removed. And what is the removal of oxygen? We call that reduction. Now look at carbon monoxide, 3CO. From this reactant side to this product side, what do you notice? The number of oxygen has increased. And what is addition of oxygen or increase in the number of oxygen? That is oxidation. So in this equation, you see that oxidation is taking place and reduction is taking place. This is a redox reaction. In terms of hydrogen, oxidation is the removal of hydrogen from a compound, while reduction is the addition of hydrogen. So let's look at something. This is hydrogen sulfide and this is chlorine. What has happened? From here to here, let's see, from here to here, you see that hydrogen has been removed from hydrogen sulfide. And what is the removal of hydrogen? Oxidation. Now look at chlorine. From just a chlorine molecule, it has become hydrogen chloride. Look at it. HCl. From just chlorine molecule. What has happened? Hydrogen has been added to chlorine. And what is the addition of hydrogen? Reduction. So once again, you see that oxidation and reduction are taking place simultaneously. In terms of oxidation number, oxidation is increase in oxidation number or addition of oxidation number, while reduction is decrease in oxidation number. From here to here, what has happened? For a free element, the oxidation number is 0, which means chlorine, sodium, magnesium, hydrogen, so long they are not ions, just an element, oxidation number is 0. So here it is 0. For a simple ion, the oxidation number is the charge on that ion. When you see an element with a charge, the oxidation number of that element is the charge on that element. So here, this is zinc 2 plus, an ion. What is the charge on the zinc? 2 plus, which means that the oxidation number of zinc here is plus 2. Then for a free element, it is 0. Here, from 0, zinc has moved to oxidation number of 2. So what is increased in oxidation number? That is oxidation. So oxidation is taking place. Now, this is copper 2 plus. The oxidation number of copper here is 2, the charge on the element. Now, this is a free copper or a free element. The oxidation number is 0. So copper has changed from oxidation state of 0, from oxidation state of 2 to 0. 2 to 0, that is reduction in oxidation number or decrease in oxidation number, and that is referred to as reduction. In questions, Jamb will ask you, in which of the following option is the oxidation number of zinc increased? In which of the following reaction will or did oxidation number of zinc decrease or increase? So in any of these ways, you look for the oxidation number of the reactant, of the product. You will see the difference in oxidation number. Shortly after this, we shall be looking at how to calculate oxidation numbers. In terms of electron, oxidation is loss of electron, while reduction is gain of electron. Look at something. From here to here, the oxidation number of zinc increased. Why did it increase? Because zinc has lost 2 electrons. So, loss of electron is oxidation. From copper 2 plus to copper, what happened? Copper gained 2 electrons to change from ion to atom. So, loss of electron is oxidation, gain of electron is reduction. Now look at here. The oxidation state of zinc here is 0. But here, the oxidation state has increased, or the oxidation number. The oxidation number of copper here is not 0, but here it is 0. So, from here to here is increase in oxidation number. From here to here is decrease in oxidation number of zinc. So here is oxidation, and here is reduction. We shall see that under calculations very, very soon. In terms of electronegative species, oxidation is the addition of electronegative elements. Anytime you see that from the reactant, then you go to the product, you see something like chlorine, fluorine, oxygen. Okay, let's leave this. Okay, oxygen is also electronegative, bromine, so on. All these electronegative elements, when they are being added to an element or to a compound, that is oxidation. Anytime they are being removed, that is reduction. Now, electropositive elements like potassium, sodium, calcium, when these guys are removed, we say it is oxidation. When they are added, we say it is reduction. So these are the headings where we can look at oxidation and reduction. Let's look at oxidation numbers. Oxidation number is simply the charge a chemical species possesses. And when it comes to oxidation number, there are 7 laws of oxidation number. Now, we know that oxidation and reduction are defined in terms of hydrogen, oxygen, electron loss or gain, oxidation number, electronegativity, and electropositivity. Therefore, we need to know the charge that oxygen possesses in most compounds. We need to know the charge of hydrogen, the charge of some electronegative elements, the charge of some electropositive elements, so that we'll be able to find out the charge of other elements in the compound. For example, this is H2SO4. Hydrogen and oxygen are responsible for oxidation and reduction. So, if we know the charge of hydrogen, and the charge of oxygen in compounds, it is easy for us to calculate the charge or oxidation number of sulfur. Let's look at the rules. The first rule states that the oxidation number of any free element is equals 0. So, if you have sodium, the oxidation number of sodium is 0. Sulfur is a free element, just an element, it is 0. Free element means the element without a charge. The oxidation number of any simple ion is equals the charge of the ion. When an element carries a charge, whether positive or negative, the oxidation number of that ion is the charge on that ion. Look at this. This is Ca2+. This is calcium ion. The charge on this ion is 2+. Therefore, the oxidation number of Ca2+ is simply equals +2. That is it. This is an ion S2-. The charge is -2, which means the oxidation number of this simple ion is equals the charge, that is -2. Now let's proceed. The algebraic sum of oxidation number of elements in a compound is equals 0. Algebraic sum means addition. So the addition of oxidation number of elements in a compound is equals 0. What is a compound? Compound contains 2 or more elements chemically bonded together. This is a compound and this is a compound. So if the algebraic sum of the oxidation number of all the elements in a compound is equals 0, it means that for H2SO4 we have 2 hydrogen. So 2 times the oxidation number of hydrogen plus we have 1 sulfur plus oxidation number of sulfur plus we have 4 oxygen plus 4 times the oxidation number of oxygen. Everything is equals 0. So the sum of each of the oxidation number equals 0. For K2CrO2O7, the algebraic sum of all the oxidation number is equals, we have 2 potassium, so 2 times the oxidation number of potassium plus we have 2 chromium, 2 times the oxidation number of chromium plus 7 oxygen, 7 times the oxidation number of oxygen. The sum of all their oxidation number is equals 0. That is what this law is trying to tell us. And the next one says the algebraic sum of oxidation number of elements in a radical is equals the charge on the radical. Charge on the radical. What is radical? Radical is simply group of compounds that possess a common charge. If I give you something like this, SO3 2-, this is a radical. When you have more than one element combined and they have a common charge, they are referred to as radical. So the algebraic sum of the oxidation number of each of the elements should be equal to the charge of the radical, which implies that here will be oxidation number of sulfur plus we have 3 oxygen, 3 times oxidation number of oxygen. Everything should be equals -2 instead of 0 because this compound possesses a charge. So radical is a compound that possesses a charge. If you see compounds with a charge, each sum of their oxidation number, everything should be equals the charge on the radical. So let's see the other rules. In all compounds, the oxidation number of fluorine is -1. Fluorine is a very electronegative element. In fact, fluorine is the most electronegative non-metals and it is the most reactive non-metal. And it is special. Anywhere it enters, it maintains its oxidation number of -1. Nothing changes it. Meanwhile, hydrogen in most compounds possess oxidation number of +1. But anytime you see lithium hydride or calcium hydride, the oxidation number of hydrogen becomes -1. These are binary hydrides. Hydrides are hydrogen combining with metals. So if you don't see lithium hydride or calcium hydride or hydrogen combining with metal, oxidation number of hydrogen will simply be +1. Oxygen in most compounds we have oxidation number of -2. In most compounds you see, the oxidation number of oxygen remains -2. But in peroxides, like hydrogen peroxide, H2O2, potassium peroxide, K2O2, and calcium peroxide, CaO2. In these guys, hydrogen peroxide, H2O2, potassium peroxide, K2O2, calcium peroxide, CaO2, all these are peroxides, and the oxidation state of oxygen is -1 in peroxide. Apart from peroxide, in other compounds you will see, and in most compounds, the oxidation number of oxygen is -2. That being said, let's answer these questions. From here, the oxidation number of, we are looking for the oxidation number of sulfur. Here, we are looking for the oxidation number of chromium. Here, we are looking for the oxidation number of sulfur. Let's start with this simple compound. For SO2, the algebraic sum of the oxidation number is 0 because it is a compound. So, oxidation number of sulfur plus, we have 2 oxygen, plus 2 times oxidation number of oxygen is equal to 0. This is S plus, oxygen is -2 in most compounds. So 2 times -2 is equal to 0. S, 2 times -2 is -2. So S plus, 2 times -2 is -4. S plus -4 is equal to 0. S plus times minus is minus. S minus 4 is equal to 0. Therefore, S equals 0 plus 4. S is equal to 4. So, the oxidation number of sulfur in SO2 is 4. That is why we refer to this guy as sulfur 4 oxide. Now, in H2SO4, we've been able to establish this. 2 times plus 1, which is oxidation state of hydrogen, plus S, plus 4 times -2, which is the oxidation state of oxygen, is equals 0. This is 2 plus S minus 8 is equals 0. S is equals 6. This is why we refer to this as hydrogen tetraoxosulfate 6. Sulfate 6, because the oxidation state of sulfur or sulfate is 6. Here, let's see. Oxidation state of potassium is +1. Fluorine is always -1. So we have 2 times potassium plus 1. Potassium is in group 1. So oxidation state is +1 plus 7 times -2. Oxygen is -2 equals 0. We are looking for chromium and there is 2 chromium. So 2 times chromium. 2 times +1, that is 2, plus 2Cr plus 7 times -2, that is -14. That is equals 0. Therefore, 2Cr, 2 minus 14, that is -12, is equals 0. 2Cr is equals 0 plus 12, that is 12. Now, we have 2Cr equals 12. We are not looking for 2Cr, we are looking for Cr, that is chromium. We divide both sides by 2. Here divided by 2, here divided by 2. 2 cancels 2. 12 divided by 2, that is 6. So chromium is equal to 6. That is the oxidation state of chromium. This is why we refer to this compound as potassium heptaoxo dichromate 6, because the oxidation state of chromium is 6. In this case, this is a radical. Oxidation number is the charge on the radical. So we simply have S plus 3 times -2. Everything is equals -2. S 3 times -2, that is -6. So this is -6 is equals -2. S is equals -2 plus 6. S is equals 4. If I am correct. So this is sulfur 4 oxide, because the oxidation state of sulfur is 4. But normal SO3, the oxidation state is 6, because for a compound, oxidation number is equals 0, the algebraic sum, giving you S plus 3 times -1 -2 for oxygen, equals 0. This is S minus 6 equals 0. S is equals 6. So this is for 6. This is for 4 because it is a radical. And oxidation number of radical is equals the charge. Ladies and gentlemen, let's see oxidizing and reducing agents. Up to this point, we've been able to really look at oxidation and reduction. For example, in this case, we know that from here to here is oxidation. And from here to here is reduction, addition of hydrogen. Removal of hydrogen is oxidation. From here, we know that from here to here, reduction is taking place, removal of oxygen. And from here to here, oxidation is taking place. We know that from here to here, oxidation is taking place. And we know that from here to here, reduction is taking place. From here to here, we know that oxidation is taking place. Increase in oxidation number or loss of electron. From here to here, we know that reduction is taking place. Decrease in oxidation number or gain of electrons. From here to here, we know that reduction has taken place. Loss of oxygen. And from here to here, we know that oxidation has taken place. Gain of oxygen. Now look at it. In this place, we know that hydrogen sulfide is oxidized. From here to here, we know that iron 3 oxide is reduced while carbon monoxide is oxidized. From here, we know that ammonia is oxidized. Then oxygen has been removed because we have 10 oxygen here. We have just 6 oxygen here. It has been reduced. From here to here, zinc has been oxidized. Copper 2+ has been reduced to copper. From here, copper oxide has been reduced to copper, while hydrogen gas has been oxidized to give us water. Now, the one that is oxidized is the reducing agent, and the one that is reduced is the oxidizing agent. That is the basis of oxidizing and reducing agents. So this covers everything you need to know. If in any reaction you know the one that is oxidized, that is a reducing agent. In this case, hydrogen sulfide is oxidized, it is the reducing agent. Chlorine is reduced, it is the oxidizing agent. The one that is reduced is oxidizing agent. The one that is oxidized is reducing agent. Here, iron 3 oxide has been reduced, it is the oxidizing agent. Carbon monoxide has been oxidized, it is the reducing agent. Ammonia has been oxidized, it is the reducing agent. Oxygen has been reduced, it is the oxidizing agent. Zinc has been oxidized, it is the reducing agent. Copper has been reduced, it is the oxidizing agent. Copper oxide has been reduced to copper. Since this one has been reduced, it is the oxidizing agent. Hydrogen has been oxidized. Since hydrogen was oxidized, it is simply the reducing agent. That is the concept of oxidizing and reducing agent. If you don't know the one that is oxidized or the one that is reduced, these other definitions and explanation will help you understand oxidizing and reducing agents more. Oxidizing agents are the ones that cause oxidation, and reducing agents are the ones that cause reduction. Oxidizing agents are electron acceptor. Now, remember, under acids, bases, and salts, we said that acids are electron pair acceptor, while bases are electron pair donor. Now, does it mean acids are oxidizing agents and bases are generally reducing agents? Yes, you are correct. Its oxidation number increases. For an oxidation number, for an oxidizing agent, the oxidation number increases. Why? Because it has been reduced. It has lost electron. Its oxidation number will decrease. Now look at this. Zinc, the oxidation number has increased. It is the reducing agent. Copper 2+, the oxidation number has reduced. It is an oxidizing agent. Why did the oxidation number reduce? Because it has gained electron. Now, why did the oxidation number here increase? Because it has lost electron. So loss of electron is oxidation, gain of electron is reduction. Examples of oxidizing agents are oxygen, MnO2, H2 hydrogen peroxide, acidified KMnO4, potassium heptadichromate 6, concentrated HNO3, hot concentrated H2SO4, and non-metals generally are oxidizing agents. Then iron 3 chloride and sulfur 4 oxide. So these are examples of oxidizing agents. If you see these ones in an equation, it is easy for you to pick them out as the oxidizing agents, even if you don't know whether they are being oxidized or reduced. Here, hydrogen is a reducing agent. As you can even see here, it is a reducing agent. Carbon is a reducing agent. Carbon monoxide is a reducing agent. Hydrogen sulfide is a reducing agent. Ammonia is a reducing agent. Iron 2 chloride is a reducing agent. Iron 3 chloride is oxidizing agent because it will be reduced. Iron 2 chloride is a reducing agent because it will be oxidized to iron 3 chloride. Potassium iodides and metals generally are reducing agents. Non-metals generally are oxidizing agents. Metals generally are reducing agents. Then lithium tetrahydroaluminate, sodium bromide, all these are reducing agents, oxidizing agents. We have tests for oxidizing and reducing agents. The first test is that oxidizing agent will turn green solution of iron 2 chloride to brown. Iron 2 is green, then iron 3 is brown, which means it has oxidized iron 2. Oxidizing agent turns green solution of iron 2 chloride to brown. That is test number 1. Test number 2, when oxidizing agent react with hydrogen sulfide, it will leave a deposit of sulfur. So when you add oxidizing agents to hydrogen sulfide, a deposit of sulfur will be left. And test for reducing agents. Reducing agents will change the color of acidified potassium permanganate from purple to colorless. So MnO4 ion radical, it will change it to Mn2+. It has been oxidized. Color of potassium permanganate from purple to colorless. Also, reducing agents will change potassium heptadichromate 6 from orange to green. It is initially orange. When reduced, it will go to green. So these are oxidizing and reducing agents. And one thing else Jamb wants you to know under oxidation and reduction is understanding redox equations. But according to Jamb, you don't need to be very good at redox equation. You simply need to know how to balance ions in redox equations. It is an objective question, so not theory where you'll be solving and deriving. So there is a typical question Jamb wants you to know when it comes to balancing of redox equations. Look at this. In this equation, we are asked for the value of y. What do? We simply balance the ions on both sides of the equation. So for this radical MnO minus, we have -1, that is the charge, plus y, plus we have ion 2, Fe2+, but there is 5 in front of the ion 2, which means 5 will multiply the charge to give us 5 times plus 2. So this is for the reactant side. This should be equals the charge on the product. So for the product side, we have Mn2+. So the charge there is +2. Then plus, we have ion 3, Fe3+, and that is 5. So 5 will also multiply 3 plus 5 times plus 3. Plus, we have 4H2O. For H2O, there is no charge. It is just a compound. And for a compound, the charge is 0. The oxidation number of a compound is the algebraic sum of elements making of compound will give you 0 oxidation number. So we have 4H2O. That is 4 times 0, which will still give you 0. From here, -1 plus y plus 10 is equals +2 plus 15 plus 0. Y plus 9 is equals 17. Y is equals 17 minus 9. Y is equals 8. So the value of y is 8. And looking at option D, 8H plus is the same thing as 8 times plus 1. And that is equals 8. So that will do, because that is a total of 8 ions. Option D is the correct option. What are the possible oxidation numbers of an element with atomic number 9? That is 1, 2, 3, 4, 5, 6, 7, 8, 9. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. This is fluorine, but we don't care the element that it is. What we know about this element is that it needs 1 electron to complete the configuration. It has 7 in the outermost shell. Two things can happen here. This element can decide to accept 1 electron to complete its configuration. When it accepts 1 electron, it becomes negatively charged. That is a charge of -1. Now, this element can decide to give out all the 7, which is nearly impossible in chemistry. But if that happens, and this guy decides to foolishly release 7 electrons, it will give you a charge of +7. Because when you give out electron, you become positive. When you receive, you become negative. So the oxidation state will likely be -1 or +7, as seen in option D. And up next, in which of the following reactions does reduction take place? Reduction is electron gain. Oxidation is electron loss. If you look at all these options, from option D, you see that hydrogen ion gained 2 electrons to give you hydrogen atom. But for the others, you see that electron has been lost, minus electron, minus electron, minus electron. It is only in option D that +2e happened. Ion gain electron to become an atom. Option D is the correct option. Ladies and gentlemen, I won't be able to solve all the questions in this word. However, I've given you everything you need to answer any question under oxidation and reduction. Is it from this definition? Is it from calculation of oxidation number? Is it oxidizing and reducing agents? Everything you need are given to you. What you simply need to do is get the Flashlearners Jamb app and open to chemistry. Then choose topic, choose redox reaction. You will see questions only under redox reaction. Be answering and playing with them. That is very, very recommended. In fact, after every video, go to the Flashlearners Jamb app and play with questions. The more you watch the videos and answer questions, the more your confidence. You won't be scared of facing Jamb like you're probably already very scared now. And when you install the Flashlearners Jamb app, make sure there is the name Flashlearners and there is the logo Flashlearners, because some persons install the wrong app and at the end complain to me. No, if you are even bothered or you don't know the app to install, chat me up. I'll send you a link. It is Flashlearners Jamb, boldly written. So, ladies and gentlemen, with this, we come to the end of this episode. Get your Flashlearners Jamb app using this YouTube description or visiting flashlearners.com, or you reach me directly on WhatsApp. Take care of yourself. See you in the next topic. That should be electrolysis.